Hey everybody, Morgan here, coming back at you talking about redox equations in acidic solution. And yesterday we talked about the first four on this homework number 1. Today we're going to do a couple from the back and then let you kind of finish off the rest of them, and we'll be collecting this beginning of next week. Okay, so this would probably be the time that I'd be asking if anybody has any requests for any of these, but that's not going to work out so well. So instead, I'm going to pick a couple that I think are good to focus on. I've always liked number 6, and this turns out to be the reaction that I showed you on the very first day of chemistry. This is the Ira-Remsen demonstration, where copper turns into copper 2+, and HNO3 turns into NO gas. One copper, one nitrogen, one nitrogen. Okay, that's good. No oxygens. Here I've got 3 oxygens, and on the other side just 1. So I'm going to add 2 waters. No hydrogens. 2 times 2 is 4, but hey, I've already got 1 here. So I really only need to add 3 H pluses. Okay, now for my electrons. That's a 2+, so I'm going to add 2 electrons on that side. And over here, I'm going to add 3 electrons. So I want to make a big deal about something. Electrons are on the right in the first equation. They're on the left in the second equation. They have to be on opposite sides. So to make the electrons equal to each other, I'll multiply this by 3 and I'll multiply that by 2. So 3 Cu gives me 3 Cu2 plus 6 electrons, and then 6 electrons plus 6 H pluses, okay, are going to react with 2 HNO3s to give me 2 NOs and 4 waters. When I do that, the electrons themselves cancel out, and I end up with 3 Cu plus 6 H plus 2 HNO3 to give you 3 Cu2 plus 2 NO and 4 H2Os. Okay? That's one of my favorites there. I think it's a good one for you to practice through. Now, I thought I'd come down and do number 9 because it's a much more complicated one. As2O3 turns into H3ASO4, and NO3 minus turns into NO. So I got 2 arsenics here, but only 1 on that side, so I'm going to put a 2 there. I've got 1 nitrogen, so we're pretty cool on that. Okay, oxygens. I've got 3 here. 2 times 4 is 8. That means I need to add 5 waters. 3 oxygens and only 1, so I'm going to add 2 waters. All right, now for the hydrogens. 2 times 5 is 10. And here 2 times 3 is 6. So that's going to be 4 H pluses. 2 times 2 is 4, so on this side, 4 H pluses. All right. Now, I'm actually kind of getting excited here because this is going to be simpler than I thought. I have a 4 plus, so I'm going to add 4 electrons. 4 plus and 1 minus, I'm going to add 3 electrons. Not so bad. That's a 4, that's a 3, so I'll multiply that by 3 and I'll multiply that by 4. Okay, so what am I going to end up with now? Let's rewrite this. 3 times 5 is 15 waters, 3 As2O3 to give me 6 H3ASO4. 3 times 4 is 12 H plus, and 12 electrons. The only reason I'm doing these in different colors is to make them easier to see. That's something that's completely up to you. And here, 3 times 4, so we have 12 electrons plus 16H plus 4 nitrates to give me 4 NOs, and 2 times 4 will be 8 waters. Okay. Lots going to cancel out. That's what I was getting excited about here. 12 electrons will cancel 12 electrons. The 12H plus will turn 16 into 4. 8 waters will turn 15 into 7. Okay. So what do I have? 7 H2O plus 3 AS2O3 plus 4 H plus and 4 NO3 minus. If you remember in last chapter, you see that's a strong acid that dissociated. Give you 6 H3 ASO4 plus 4 NOs. Overall, the charge on both sides is 0, so it's balanced out. Okay, so I think that gives you a pretty good grounding in how to do these. So we're going to let you finish off the last 3 and check Schoology for the due date on this. It'll probably be about Monday or Tuesday of next week. And when you submit it, make sure that we can see both sides of the homework. Either photograph both sides and give you 2 photos, or scan both and upload both as PDFs. Okay, this is Morgan, signing off.